So you might look at this chemical equation and say, hey, wait a minute, how can we have a fractional coefficient here? That would mean we have like part of a molecule. And if we have part of a molecule, doesn't that change the molecule? And the chemical equation doesn't make any sense. But here's why it's okay. These numbers in front here, they're called the coefficients. And the coefficients, they don't really represent individual atoms or molecules. What they represent are the ratios of all these compounds together, how the reactants actually combine to form the products. They are the ratios, and that's the key. So here's an analogy that might help you understand that. If we have the fraction 6/12, we could simplify that to 3/6, or even simplify it further to 1/2. These are all the same ratio. They represent the same number, 0.5, just they're written differently. Same thing with the coefficients here. We could change these. If we multiply everything by 2, we end up with whole number coefficients, like this. And often teachers like you to do this so you have these whole numbers here. So now we have 2, 7, 4, 6. Those are the coefficients, and it's the same ratio as 1, 7/2, 2, and 3. In fact, when you're doing chemical problems like stoichiometry, where you're trying to predict the amounts of substances, you could use these coefficients here or these coefficients here, and you're going to get the same answer. There's really only one instance where it matters that you need to use whole number coefficients, and that's if your teacher wants you to. So the key idea here, in chemistry, we're really interested in the ratios of the coefficients, not so much the specific number, but the relative ratios between substances. And if your teacher likes whole numbers, use whole numbers. This is Dr. B. Thanks for watching.